Okay, I was contemplating how best to use this session, and I was thinking of one of three topics. To wit, a discussion of uh, it's a very sort of operational, more software engineering discussion of, or at least programming understanding of linking with the Rust code base as guided by as reflecting the guidance given to me by Alex and Eric on basically having Rust code that can make use of the CatCoLab Rust code base, particularly the catalog section of it that supports double theories, double models, and now double instances. The second possibility was to talk about representable functors, and representable functors build the understanding behind them built hugely on the concepts we've been talking about in the context of profunctors. And having discussed profunctors now, you're exceptionally well equipped to take on representable functors, and representable functors are one of the most important elements, both at a practical level and at a theoretical level in a whole area of category theory. And they come in, and they're very, they've already appeared or played a notable role in ways I've had to kind of wave my hands at them in the context of things like a C-set colem, that construct that we construct to sort of concisely describe a C-set as a colimit, where we can say, there's a wolf and a sheep whose locations are the same. So we have a wolf, we have a sheep, and they have the same location. Or we have a veteran and a dog, and the dog, the dog is accompanying that veteran, what have you. They also play a very interesting and intriguing role in terms of kind of serving as the building blocks for our C-sets. In many ways, they're the kind of the little pieces out of which we build up our C-sets. In some sense, they delineate natural pieces of stock flow diagrams, for example, or natural pieces of causal loop diagrams. The things that kind of go together. And so that was the second possibility. The third possibility involved talking about tabulators and an understanding of that arrow category and why the tabulator leads the arrow category. Now, unfortunately, the later, I'm brutally busy this week and next with a bunch of deadlines. Some of them last night, some tonight, some next Friday. And I had aspirations, at least to representable functors, but I've just had no chance to prepare, and I don't think I could do the I don't think I could offer the quality. I could muddle through it, but I don't think I'd offer the quality and sort of impassioned delivery that it merits. So we're going to wait on that for a week or two till I find time to invest in it to teach it in a way that um, that is worthy of you. Um, and instead, I find myself in a position to talk about the first of those topics, namely the one from the programming perspective. And well, I say that with a measure of resigned uh, resignation in my voice. And in fact, I'm actually extraordinarily excited about this. And at least I can authentically translate this excitement into coverage that I think will offer some um, some practical opportunities for each of you. So I'm really delighted here to share some great news. Alex and Eric joined me early in the week to work together to figure out how to set up a test harness with respect to the CatCoLab codebase. So the idea is that while CatCoLab has a astoundingly farsighted and admirable commitment to providing an online interface for creation of models by anyone. For power users like in our group, I also wanted recourse to building models, and I use that word advisedly, that in a programmatic way. Build small programs that will use the CatCoLab code base to build up, compare, reason about, modify, analyze, and interpret double models and double theories. And to do this, I had to learn some Rust. And Alex and Eric made this a very straightforward process, and I'm so grateful to them for that. So in short, I get cloned the CatCoLab code base earlier, and then I built up a little test harness with a lot of guidance from them on some of the particulars of how to link it in with cargo and the build system. And then it was off to the races, and now I can build up little compositional causal diagrams within as double models. So I'd like to show you what we did, and maybe some of you will feel inspired to do said things. And Eric and Alex can sort of clue me in on when I'm off base and correct me, as always. Okay, so I'm going to go, just a sneak preview. This is my code here to build up compositional causal loop diagram of the sort you're of which you're very familiar, with which you've enjoyed the pleasure of acquaintance, by building it up with Rust code. And it makes use of CatLog, including its double theories and double models. And it does so in a way that that makes use of the double theory and double models. This is okay. So some of these descriptions have to be updated, but it does so in a way that takes advantage of the ways in which double theories and double models work. Okay, and so let's talk about this. And Eric and Alex here can remind me of things that I'm forgetting to narrate. But one of the most important things that we did early, besides Git cloning, CatCoLab, and installing Rust, is through Rust Up or something mumble, which brings in cargo. Is we went and we looked at the, so in the kind of area where I Git cloned it. So here, let's see, where did I actually do the Git clone? I think I did it in CatCoLab here probably, but no, maybe it was in here. I think it was in here that I did it. In any case, there's a cargo.toml file here, and I if you cat it, you'll find this is the describes the information needed to perform its building, and we added a test harness package to this for my test harness, my test driver, right? And following that, we went into packages and we created a packages test harness. Okay. So within packages, we have this little test harness, created a folder, the SRC folder for source, and I created main.rs. Sorry, Eric, were you saying something? I also we also create a cargo toml here, which basically provides build information for this package. So there's kind of the cargo.toml for the top level structure that provides the build information for the top level. And then each package, as I understand it, has its own cargo make information that tells how to build it. And here we have some package information. And this addition somehow is the addition of mumble. Alex said it's Alex, what is this? The addition of Rust or something, or the addition of cargo or something? Cargo? Okay. And I just copied these things. I'm not sure. I'm clueless as to what's going on here. I should probably learn what's going on. I certainly don't need the ODEs for this or the WebAssembly. But I think this basically does point it to CatLog, the CatLog package, which is located one level up from this. It's located in packages. And I guess this, Alex, this describes like the sub pieces of CatLog that it needs or something.
I think it enables like additional modules in CatLog.
Okay. Yeah.
But I'd have to look more into that.
Right. So this really, could probably be empty in my case. So anyway, that was some kind of infrastructure that I put into place. The real more interesting, substance of matter was, of course, building up the bit of code. And I kind of muddled through this, but uh, basically, I'd say I want to use a bunch of things in CatLab, and it turns out to require not just things in, sorry, catalog, and not just things in catalog's double model and double theory support, but also things at the zero level of catalog. And I think those are sort of the object side or what have you. I did need this. I needed theory signed category, which is used to create basically the theory for causal diagrams. It's a signed category. You saw that before from both a pro-functor perspective and from a perfect high level perspective, kind of recognizing that each of the types of pro arrows turns into a kind of flavor of morphism, plus minus. And then there was some other stuff. This arc thing, I think, is probably used somehow for, like, I know Rust has this ownership, this notion of ownership or what have you, and it seems arc has something to do with sort of references in that sense, what has to be cloned or what isn't cloned or what have you. And I maybe Eric or Alex could comment on that. It's not particularly urgent, but I sort of had found that I had to futz with that, like to wrap arc around things. Instead of using double theories directly, I had to use arc around them. And I suspect it has something to do with this notion of, to have really performant memory management, which is one of Rust's sort of claims to strength, and to performance. It has really good memory management that doesn't require garbage collection, but does so through a certain discipline using typing. And I suspect arc is part of that. Alex, I don't know if that's anything you could comment on at all. This is probably something to do with
Sorry, I was just looking into the
Mm.
what we
So just what the role that arc plays here. I don't. I'm.
I think it's like an automatic reference counting type of thing for Rust. Has to do with the memory management.
Yeah. Okay. Okay. Right. Anyway, so I
Yeah,
needed. Sorry. Alex.
it stands for atomically reference counted, so it's just a reference counting.
Mm. Mm. So there's some cases where it seems to want things that are wrapped in arcs rather than, just directly like double theories. Here it's, I get an arc of a double theory, and then I clone that theory every time I use it, like to create a new model that's based on it. I guess to avoid any worries that the theory will be, that its internals will be mutated in some way. Anyway, so I kind of started in a very modest way, but what I ended up going to is to have a theory of a theory signed category, and then made sure it was sane. And then I created a double so this is a double theory, right? Wrapped up in this kind of thing for memory management. And then I created a double model that was a positive loop, and I made sure that was okay. Okay, fine. But then the more substantive thing I did was to create a causal loop diagram. And again, I cloned the theory to pass it in for this causal loop diagram. And this smoking causal loop diagram returns a double model. And basically This is a new one. It's not this one. This one is the positive loop one that I created. This is kind of a motif that we can look for which we can search, right? Declared in the code base. Here I'm building it up. So I create a new one. And then I'm going to keep on using these positive links and negative links. So I create an object to represent positive links and negative links. This is um kind of a pro arrow here. As I understand, I'm not sure why it's called finite morphism. In any case, it's a generator negative, and this is the idea. You may recall that the identity pro arrow serves as positive links. Excuse me. Yes. This is causal diagram. Yes. Identity pro arrow serves as negative links. Or sorry, positive links. And the negative link is represented by the other pro arrow, which is negative. And this negative thing is defined in this theory signed category in the CatLog code base. And so then I kind of cons together a bunch of stuff. I created this object name and I added it in as an object. I added in another. So these are my object. Remember that when we were dealing with C-sets or attributed C-sets, attributes with CatLab, we were dealing with C-sets, right? Here we're dealing with C categories. And remember, that gives us compositionality. Right? Each object in the theory turns into a category. And within that category, for the model, are a bunch of objects for each of the items in the model, in this case, in the causal diagram. Now, I'll see if I can find this little diagram. I should have had it here. I think it's this one here. Yeah, it's this little diagram that I'm building up. So in a double model context, each of these is a object, right? So here's our smoking object as a category, right? And as a result, there's compositionality. As a result, there's a morphism from smoking to itself that represents the composition of all three of these arrows, which are links, which are morphisms in the category. Because there's composition, any pathway, like from smoking, this commitment to cessation has a morphism there, right? From smoking to commitment to cessation. But here, all I have to build up is the generators, what's shown here. And the rest is implied by the rules of categories. And it comes with the compositionality of this being a category. So I'm going to add in each of the objects in turn, smoking, nicotine addiction. I do this one first. And then I add in the morphisms, smoking to nicotine addiction. And I need to clone this probably for some, again, memory discipline thing, make sure it doesn't mutate it, right? And the same thing for nicotine addiction, increases smoking. So this is our first feedback. Sorry, this one right here. That's exactly this one. And because we're adding these things to a double model, again, we get compositionality for free. So there's automatically one going from smoking to itself by virtue of this plus here. Okay, of this plus loop. Okay, then we add the second feedback here, which is the lower one here, right? Smoking to health. Both these upper ones were positive links. Here we have our first negative link. So we've added into health and we've added a negative link. I didn't bother doing the delay. There is support now for delays, one step at a time. I didn't want to try that until I got my footings on the basics. Negative link. And then I added a commitment to cessation, added that object. And a negative negative link to that, etc. This would be a natural. I think I'm going to create a function to capture some of these higher level abstractions, software engineering wise, just yearning to be captured. You get lots of these kind of pairs of things. It's a name and then some use, and the issue is like you need the name at different places, not just here. You need it later, etc. So it'd be better if we had a little function that did both these things, and it modified the model and got back this name. I wish it were more functional, but that's another matter. And so then basically I add these various negative links, right? And then I add the third feedback loop and kind of mutatis mutandis, and I've got to go change these things. Anyway, while I was building this up, of course, I was going and making this. So I was doing cargo build, and I don't know why it's rebuilding this. I mumble. Certainly wasn't doing this before, but it was basically I would build it in quick order and make sure it worked properly. This has a bunch of warnings, but no errors. And then I can go and I can run it in the I should have just done it by running it in the target debug area. So, okay, this is interesting. Of course, of course, I know what's going on. I really should have done that right. I should have been compiling it. I could have been compiling it from up here. That's where I was compiling it before. So, cargo build. This would do it at the high level. This is in the folder with all these things. So it's actually building the full system. It had already built the other things. And as I'm modifying this code base, it'll modify it. So I'll go add something here and
Sorry,
add yes, Nona.
this warning is told we should change the name of CLD to the CLD is the capital for defining function.
Just a minute. So the CLD is for causal loop diagram, right?
Because in defining function after smoking, CLD is written capital and
so this, yeah.
yeah.
It doesn't like this being written capital, but I said, nuts to that. I mean, this is an acronym in English. I'm not gonna make it all lowercase, just because it's persnickety. And so yeah, it doesn't like this being capital, and I'd say, well, tough luck. I'm gonna do it anyway. And you're not gonna be able to stop me. So sorry, it's an acronym. I want to read it as an acronym. I don't want to read it as if it's a word. So I told it go, okay, fine. But in any case, that's why I kept it a capital. It doesn't like it, and yeah. In any case, That's why I named it that. This is a function and it returns a double model. So all this is built up, right? So I'll build it here after my, adding that comment, but it returns the model that it built up. So this is the model built at the or constructed at the beginning, right here, where I'm adding each of these loops. And this is ugly to me. I should divide it up into 3 subfunctions, each adding a loop. But in fact, it's quite hideous to me right now. But I basically return the model and that I created at the beginning, and that's a UString discrete double model. And then it goes and it validates it in some trivial form. My next step with this is I want to do motif finding of a positive feedback loop. So I built a positive feedback loop here, and I want to do motif finding through by having a functor from the category associated with well, basically I want to do motif finding through a functor, and so finding positive loops within this causal diagram and finding negative loops in the causal diagram and enumerating them. That's my next kind of little step that I want to do on here. I'm having great fun with this. This is just like just wonderful. So here we return our model and we're off to the races, and we can do things with this. And of course, while doing all of this, I was going through and going through our, the CatCoLab code base and looking at how they did things, going particularly to their tests and seeing how they did. Like, I basically got an understanding about how to use these things through by looking at what they do here and seeing how they create new models or create new theories or what have you. And that was extraordinarily helpful. And if any of you want to follow my footsteps, you could do it through that. I would once again highlight the utility of being able to refer to different parts of the code base as I have recorded them within this document, resources for understanding of different categorical subareas in the double categories area. I have all these links to things in the Rust code base in descriptions of what they include, what affordances that they offer, or things they support. For example, theory sign category is located here in this one, and that's one of the things I'm using here. So theory category, theory empty, theory schema, which is a walking pro arrow because it's conceptually you have the normal objects and HOMs and the category and one objects and HOMs, and then you have another category for attribute types with arrows actually between them, and you have a profunctor between the two. We talked about that before. This is a theory of signed categories, and causal diagrams are supported by that. So this is the theory of signed categories that I am using here, where there's a single object, there's an identity pro arrow always with any object, and then there's a single morphism from a single non-identity pro arrow from that object to itself, which called n, that's going to represent negative signs and negative links. And if you compose profunctor n with pro arrow n with pro arrow n, you get the identity pro arrow. So that's the theory of signed categories that I make use of here. and then I import here. So maybe I should go and put this. I'm gonna go and I'm gonna put this is a horrible code, but it's from a software engineering perspective. I think this is unworthy, but at least what it lacks in being nice, it makes up for, and being at least sort of brutally straightforward. So what I'm just going to do is I'm going to fix some of these labels, and I'm going to post this to you, and you can go off and play with it if you want to. So this is like time spent around other smokers leads to closer relationships with said smokers, with those smokers. Okay, fine. And closer relationships with those smokers leads to more smoking, to greater time smoking, greater smoking. Okay. To increase smoking. That's the right word for it. Okay, maybe I'll make sure this compiles, and I'm building it from the main thing with all the packages underneath it and so on. Happy, happy. And now I'm going to post this to the category theory group, and people, if they'd like to partake of it, they may do so. I'm also going to post my cargo in my subfolder, in the test harness package subfolder. Okay, so here we go. So here's my cargo. So that's for the build system, and then I'm going to. I'm sorry. That was the main cargo, and you do need that. You need the piece of that points to the test harness. So fair enough. And then I've got to go to packages, mumble, test harness, cargo. This is my the second cargo, the top cargo dot toml is for the entire system. Basically just adds the pointer to the reference to the test harness package. Okay. And then the second cargo.toml is to place in the packages / test harness folder. And then I'm going to load my source. Here's main.rs. So here's my code to build up a causal loop diagram and one archetypical motif of a positive feedback loop. This folder, or sorry, this file, main.rs, goes in the packages / test harness / source folder. Boom. Okay, there you go. If you want to play with it, it's ugly, but it works. Okay. Okay. So thanks to Alex and Eric, using CatCoLab from our own Rust code base, from our own Rust code, is easier than I thought. It's a delight to be able to work with these models. Do I think that this is what we want to do heavily? No. One thought that I had is to I want to be thinking strategically about how we're going to build up tools around this. There's a couple clear lines of contribution that I want to make. This much is clear. Number one, I want to have a canvas-based interface to double models within CatCoLab. Topos is also on side with this. They'd love it if we worked on this. Kind of takes the philosophy of model collab such that for CatCoLab, there can be a notebook type interface for building these things up interactively. But then sometimes you want to lay them out visually. You want to lay out your causal loop diagram in a nice way. You want to lay out your stock flow diagram in a nice way. And you want to retain that layout. Color things according to the role they play. Group things that are conceptually, associated with each other. Visually plugged together models. By the way, that would be like with category push-outs of categories, which you can do. Taking the push-outs of these categories we can do. To like stick together two causal loop diagrams by identifying certain objects between them. I want to have that visual interface that will prize like interaction visually with these things and persistent laying them out. And I think we want to also supplement that with information about the process by which this has been built up, its provenance, who contributed what at what time for what reason or what have you. Beyond the mathematics of the diagrams, there's the mathematics of the process and of the layout, which we can capture in categorical ways. But kind of in a similar way that we had a separation of concerns for the wolf-sheep model of where things are located on the screen from the mathematical definition of it, and we could lift the functor going between the two. We could lift things that operate on sheeps and wolves to operate, the mathematics of them to operate at the higher level visually, etc. With their information about where they're located on the screen and in the canvas. Anyway, that's one priority. The second priority, which is like that's medium term. I really want to start moving towards that. Even sooner than that, I think we could start contributing to the CatCoLab codebase. This is the first small step towards that. I think we start contributing code. Maybe at first it's documentation, but then maybe we start adding more things. Now, Cheyenne, like Topos, is not standing still here. Cheyenne, working at Topos UK, is working with David Jas Myers and Evan to add in some wonderful things like support for system structure diagrams with plus links and minus links. And you heard a little bit about that, perhaps, in our last meeting with Evan. But we want to add in better support for system dynamics diagrams. And for things we can do with them, right? Like mapping one to the other, like taking their push out, and so we can compose them and so on. Stratify them. I'm trying to get us up to speed so we can make these sort of contributions. And there's a lot more to be said about, ideas there. What else we could do with these diagrams that aren't currently captured. But basically, as soon as we want to start contributing, I think Topos is glad to have us contribute there. Even if it's documentation, that's a big step because it needs documentation. I mean, that's a big contribution. That's what I mean. That's value. Don't think of it as a small matter. So again, first big area, Canvas-based interface to CatCoLab, medium term. Immediate term, building up examples, building up documentation, maybe building up some test harnesses. And in contributing some to the growing support for system dynamics diagrams. Maybe even think about custom layout engines for those diagrams so it looks less hideous. I shouldn't say it looks fully hideous, but it definitely got a long way. A lot of opportunities for improvement. So those are two things. What's sort of the third component to this? Well, I think we want to think about other tools besides the web-based interface to build these up aimed at power users, like in our lab, like other mathematical modelers. And I want to start thinking about domain-specific languages. I pointed Alex to something, DSLs in Rust, domain-specific languages in Rust, and it's support for them, which is not via, as I understand it from her and from what I kind of got the sense, it's not Lisp macro style, sort of like inspired Julia, but it's not purely lexical like in C macros, which are, sort of just processing text, really. So I want to think about, like, how do we support people so they don't have, like, more power users, so they don't have to go through the visual interfaces, but they have a higher level. That still keeps them focused on the diagrams where possible. Could we build up? I don't know. Is there a kind of Jupyter notebook type thing for building up models with that, and in an interface like that with Rust, or with DSLs? I'm not quite sure, but maybe we add functionality to the notebook style interface that's already there in CatCoLab. I don't have a clear vision of this because I see a lot of power there in the notebook style interface. But I'm also wondering if power users need a separate interface. And I want to position ourselves strategically to get pretty clear-minded about, so we can propose something to Topos, make sure we're, that we dovetail with their development plans, and so we can divide up work accordingly. There's a lot more we can do too. I mean, there's issues of tying this in with sheaves and, temporal sheaves in particular that I'm quite interested in. There's options for supporting this with computational statistical support, and all the sort of things that we might think about at CatLab as well. outputting models in certain standardized formats. There's this format called XIL Smile. Uh, uh, I think this is how it's spelled here. An XML based system dynamics encoding format, and we might want to output things in that format. Yeah, I saw Mehdi's note. Mehdi, I'll add you to that group. Okay, so anyway, these are some ideas. This is at a focused on more of the software engineering plans and so on. It's a small initial step towards towards bigger contributions here. But for some of you who'd like to play around, I would strongly encourage, in fact, I would exhort people here to try playing around with the CatCoLab code base. Try get cloning it. Try getting my code running, setting things up where needed, asking questions of consulting with Alex and Eric and myself in the Hangouts, and let's get going so we can get soon to be able to contribute examples and documentation, and soon enough sort of features for the CatCoLab ecosystem. Okay.